Okay. So this is the first thing that we have to discuss. Okay. If we talk about this chapter with respect to the paper, so it is not that much frequently asked in the paper, but yes, wait. Okay, but yes, they ask you a lot of time in paper, right? So and you can expect one question of probably it's the first or second question of around maybe 3 to 4 mark. Okay, 3 to 4 mark maximum. Okay, and an easy scoring mark. Okay, so it's just a simple thing that you guys practice in your O levels and AS level, right? Um, okay, so by modulus we can we know that I think this concept of modulus is in O levels advanced and I think further maths as well. So, but over here, modulus only refer to any function that can take any positive or negative value, but it will always output you a positive value. Okay, so modulus is basically a mathematical operation that helps you that basically gives you all the value, yeah, everything in positive. Okay, so modulus is basically, wait. Acha, by inequality, you know how to solve the inequality. You guys um, are used to the inequalities in your AS level as well. Okay, so mm, 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 mm. So it can take any positive or negative value, right? But it always output, sorry, outputs a positive value, right? This is the simple concept. Let's imagine a function. Let's say y is equals to x plus or x, let's say x minus 2. Okay, this is a function, right? So you can see that, or come on, it's a straight line equation, right? If I draw it, so it looks like this. Okay, y and x. Okay, so positive gradient but negative intercept, right? Let's say like this, right? So this is going to be negative 2. Okay, and at this point, come on, at this point it would be, if you put um y0, so x would be just 2, right? So this is a normal function, right? But if you apply the modulus, okay, so if you apply the modulus on the same function, then it will look like this. Let me just have it in the modulus form. Okay, modulus is always represented by two vertical lines at the beginning and at the end of the expressions, right? Can I convert it in the graph? What? It's making the same thing. Nope, not reading the modulus. Okay, fine. So if you have the modulus, then it will always going to give you the positive value. So the graph will only reach to that point, okay, and then it will be just finish there, or you can just make the reflection, right? like this. Okay, so the modulus function looks like this on the graph, right? So like if let's say you put the negative, you put -2 for x, okay, so that will give you y as -4, right? But since we have a modulus on, so the modulus will convert that negative into the positive, right? So at x equals to -2, let's say, what we write here, -2, your y would be +4, so it would be +4 right there, right? So any negative number that you input in a function, in a modulus function, it will always give you a positive output, right? Is that clear? Is this concept clear? Yes.
Yes.
Yeah.
Good. Now, by the way, since modulus function is converting all the negative sign into positive sign, so can you guys recall any other mathematical concept or relation that do the same thing? Like if you have the negative number, so by applying that function or that relation, it gives you the positive output. Yes, anybody?
Squaring.
Oh, nice. Very good. So basically, to solve the modulus function, okay, we can replace the modulus sign with a square, right? Make sense? Yes,
Yeah.
fine. Perfect. And wait, good. So, we also have one more thing, apart from doing a square, and that is if you just do the plus and the minus thing, so it will again give you the same thing, right? So the first method, wait, to solve the modulus function, right, is, wait, so I have method one. Okay, so, and that is sorry, replace replace the modulus with a square, both side. Okay, since everything, if you introduce anything, so you have to do it on both side, right? So square both side, both side. Okay, so replace the modulus with a square both side, then solve the function, equation, or inequality. Okay, equation or inequality, right? Let's say I have I have an inequality. Um, it's a question regarding June 2017, variant 32, paper, question number 2, right? It is basically from question number 2 of the paper, right? So the question says that solve the inequality, where you have x minus 3, okay, and 3x minus 4, right? So if you have a modulus at any side, you have to apply um, you have to apply the square both side, right? To keep the mathematical rule, um, to hold the mathematical rule, right? So if we just apply the square, if we just square everything, so we'll get, right, and you can solve it, right? So that become x squared minus 6x plus 9, and then 3 squared 9x, and then minus 3 fours are 12, 24, 24x plus 16. So solving it further, okay, so 9x, okay, so it become 8x squared, okay, and that become negative 18x, okay, and taking it to the other side, I think it would be 7, right, and is equals to 0, right? Yes. Can you solve it? Uh, if you just put in the calculator, I'm getting 7 upon 4, 7 over 4, okay, and I'm getting x as 1 over 2, right? So what will be, or what would be the answer? If you put both of the thing into your original equation to see what you are getting, okay, so if I put uh 7 over 4 in the first equation, so 7 over 4 minus 3 modulus is less than 3 times 7 over 4 minus 4, right? So we have to see that whether they're satisfying, the inequality is satisfied by this value or not. So 7 over 4 minus 3 gives me negative 5 over 3, but the inequality, but the modulus makes it positive, and then 3
Isn't
20,
it negative 5 over 4?
sorry, yes, 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 5
Negative
over
5
4,
over 4.
yeah, yeah, and 21 over 3 minus 4, so I'm getting 3. Okay, so due to the modulus, you can say that 5 over 4 is less than 3, right? Is it less than 3? Yes. This means that this answer is correct. Okay, so x would also be less than 7 over 4. Or sorry, x would be greater than 7 over 4, right? Because this thing is lesser than 3, right? And if we put 1 over 2 in the, wait, if we put 1 over 2 um in everything, so 1 over 2 minus 3 and modulus, okay, and then 3 times 1 over 2 minus 4, okay, so 3 to the 6 minus 1, 5 over 2, okay, and 3 over 2 for the 8 minus 8 plus 3, so minus 5 over 2, okay, so basically 5 over 2 is less than minus 5 over 2. Okay, so this is not correct. Okay, so this answer is not correct. Okay, like it's not possible in the inequality, so you can ignore it. Okay, right, is that clear?
Yeah.
Okay, so every time you do the question, you have to check whether both of the things are um valid for your inequality or not, right? So let's try another question. Okay, one question for you guys. So the question says that, अच्छा, June 2017, variant 31, question number 1 of the paper. Okay, and that says that 2x plus 1 and then less than 3 and x minus 2. Okay, try it quick. Done?
Almost.
Okay. Irfan, what about you? अच्छा by the way मुझे एक चीज try करनी है.
I'm finding the value of x now.
Okay.
Just 1 second.
So done?
Yeah, I'm done.
What are the values you're getting for x?
Um, I've got x is greater than 7.
Okay. And that's it?
No, there was one more value, but it didn't fit in the equality. X is equal to 1.
Okay. Actually, by the way, Irfan, are you done? So
Yeah,
basically,
I'm getting that.
okay. So if we in the first question where we're getting 7 over 4, 7 over 4 is basically 1.75. So can you see it 1.75 right here? Right? If Can you see 1.75, right? So basically, if you look at the graph, this is
Yes.
basically related to the previous question. Okay, so this red one is basically the modulus function. Okay, and this point where the red graph and the blue graph, which mean the two inequalities, because in the question they just equate the two things, right? I just put it in the separate equations, right? So the two graph intersect at this point 1.75 comma 1.25, right? And we are saying that any value of x greater than 7 upon 4 will fit in our inequality, right? Because one of the equation has that modulus sign and the other don't, right? So basically the graph follows everything in front of like every value is in front of it, right? In front of 1.75, right? Acha. So now if we just input the second inequality, that is 2x plus 1. Okay, so 2x and then we have plus 1. It's just for you to visualize how it works, okay? And I have 3, and you have only x and -2. -2, -2, and there's a modulus sign, right? So now you can see that, okay, yes, can you see that? There's one point that you guys are getting as 1, okay, or that you should get as 1, okay, and the other point would be 7, right? Okay, so basically the inequality would be valid in this region, maybe, yes, or outside this region. We have to figure that out. Okay, wait, let's just take you back to the question. Okay, so maybe when you square both of the things, so 2x plus 1 whole squared, okay, and then 3x minus 2 whole squared, okay. The graph is just for you to visualize how it works, okay. Okay, so it become 4x plus 4x plus 1, okay, and that would be 9, okay, and then x squared, then negative 4x, negative 4x, then plus 4, right? And when you solve it further, you may end up getting 5x squared, okay, minus 40x, okay, and plus 35, right? Did you guys get the same thing? Or you can just simplify it to x squared minus 8x plus 7, yes? And by the way,
Yeah.
okay, so we have that less than sign, okay, good. Now, you end up getting the x value as the critical value of x as 1 and x as 7, right? Now, so just do two things, right? Acha, by the way, you put 7 in and you put 1 in, right? So you guys said, acha, by the way, wait. So just consider x as 1, 0, and 2, and 7 as 7, 8, and 6. Okay. And let's say where these value fit in, whether these value fit in the inequality or not, right? So if we put 2 in 0 plus 1, okay, inequality, and we have 3 and then 0 -2, right? So that become just 2, sorry, here inside here, so here, so that become 1 is less than 6, right? 1 is less than 6, makes sense, guys? So
Yeah.
this
Mm-hmm,
value
yeah.
is making sense, right? But if I put 1, right? If I put 1 in, right? So it won't make sense because 2 times 1 plus 3, so it become 3. And that is 1. So 1 minus 2, -1. -1 modulus 1, 3. Okay, then. So 3 is less than 3 doesn't make sense, right? So this means this is not making sense. And maybe then 2 won't make sense either. Okay, so 2 times 2, 4, plus 1, 5. Okay, so that become 5. And if I put 2 to the other one, right here, to 2 times 2, 0, and that is 0, right? 5 is less than 0, doesn't make sense, right? Clear? So this means the values lesser than 1 satisfying the inequality, but greater than 1 does not, right? Clear, guys? That clear? Okay, let's try with 7.
Yes.
I'm just explaining this and then we'll come up with a rule, and you don't have to do it every time, okay? So for 2, and then we have x, okay, and then plus 1, and we have less than 3, and then we have x minus 2, right? So if you put 7 in, Okay, 7 and 7. So 2 times 7, 14 plus 1, 15 is less than 7 minus 2, 5. 3 is a 15. Okay, so 7 also not making sense. Okay, but if we put um 8 in, okay, so 8 and 8, okay, so 8 times 2, 16, okay, plus 1, 17, right, less than 8 minus 2, 6 times 3, 18, right, 17 is less than 18, right, so it is making sense, right, clear. And 6, if you put 6 in, right, so if you put 6 in, so 6 2 is a 12 plus 1, 13, okay, 13 and 6 here, 6 minus 2, 4, 4 3 is a 12, also not making sense, right, clear. So basically anything that is greater than 7 are satisfying the inequality, right? So over here, if I take you to the graph, okay, so basically any value greater than this one, any value greater than 7.15 will follow the inequality, and any value lesser than 1, 1 comma 3 follows the inequality, right? Is that clear? Are you guys getting it? Yes or no?
Yes.
Quick. Okay.
Yes.
Yes.
Now remember the rule. Okay. If you ever have the lesser than sign, okay, if you ever have the lesser than sign, then the x values will always follow the inequality in such a way that it will follow, like if you draw the number line going far and wide, okay, with this 1 and this 7, okay, so on the number line, if you have the lesser than sign, so anything to the anything to the left of the smaller value, okay, or is smaller than the smallest value, okay, and greater than the greatest value will be considered in your range or in your inequality, right, or in your inequality value, right? Is that clear? Is the rule clear? So you will write the answer as
Yeah.
x would be lesser than 1, okay, lesser than the smaller than the smallest value, and greater than the greatest value, right? Not equal to, right? Because we have seen that 7 is not justifying the inequality, right? Clear? Okay, so for for lesser than sign, okay, the um तो क्या कहते हैं यार the inequality will always be x is lesser than the smaller value, okay, and x will be greater than the larger value, larger, okay, and these two values are basically known as the critical values, right? So these are the critical values. Can this, wait, ping के साथ mm, 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 एक सेकंड देना प्लीज. With ping goes the screen. Okay, so these are the critical values. Okay, critical critical values. Okay, so this one, and that one, right? Is that clear, guys? One last question. One last question. Okay, so we've seen the idea when we have one modulus. Okay, so it could be any one of the answer, right? And when we have, because the graph only cuts at one point, right? Getting, guys, is that clear? Because in the previous case only the graph were cutting at one point, right? So, and the other point would be useless for us. Okay, but in the second graph, in the second scenario where we have two modulus, okay, so both the graph cuts at the two different point, right? And let me if I wait. So the graph cuts at two different point, and the values can be beyond those 2 point or can be in between those 2 point, right? So if we have the lesser than sign, then the inequality values will always be beyond those 2 point, okay? And if you have the greater than sign, then those value will be in between the two quantities, right? So this and this and this and screenshot and wait, I want these as well. And yep, आज भी लगा देते हैं. Copy and delete. Okay. Ooh, अच्छा जी. Paste. Is it visible? Yes. Okay. Now, so over here, the range is basically in this portion. Okay. Beyond this portion and beyond this portion. Okay. Now, one last concept and then this will be done. Okay. If you have the greater than sign. Okay. So let's imagine the similar, or let's just change the inequality. So the question is from November 2015 and variant 32, question number one of the paper, one from the paper. Okay, and the question says that 2x minus 5, okay, and that is greater than 3 inequality 2x plus 1, right? So this is the inequality. Okay, now can you guys please solve it really quick? By the way, there's one more easy way of doing that. I'll tell you probably after that or maybe in tomorrow's class. Okay, but just solve it first. Come on, it's not looking good. Do you guys want the equation? Or if you guys note it down, then fine. If you don't, then let me know. Come on. Now. Yes, done. Copy and delete. Okay, perfect. Hanji, what are the critical values you guys are getting?
I'm getting x is equal to 1 over 4 and x is equal to -2.
Okay. So basically the equation that you what is the equation you are getting? The quadratic one?
Uh, 32 x squared plus 56x minus 16. I didn't simplify it.
Okay, fine. Okay, so and from that you are getting x as a -2, okay, and x as 1 over 4, okay. Let's just quickly draw it on the graph and you'll see how it works. Okay, so I have 2x minus 5, 2x minus 5, okay, and I have 3, then 2x, and I have plus 1, okay, right now. So these are the 2 points where the graph are cutting each other, okay, or where the two inequalities are meeting at each other, okay. And you know that if we've seen the concept where we have the lesser than sign, so we said that it should be in between the two, it should be outside or beyond the two values, okay. Now in this case it would be in between the two value, right? You can again do the same similar thing considering a value greater than the critical value and a value smaller than the critical value and the critical value itself, okay, for both of the critical value, and you can solve, right? I'm saying these value as the critical one, right? So if you have -2, so just consider another value as -1 and another value as -3 and put everything in the x, okay, and to see which of the value will satisfies the inequality, and a similar thing goes with x, okay. So when you do that you will end up getting you will end up or you will conclude that kx will always be smaller than the greater value, right, and larger than the smaller value, right, like in between. Clear? Yes. Any idea? Any
Yes.
problem? Okay, and if you draw the number
No.
line, okay, so that would be -2 and that would be 1 over 4, 1 over 4, okay, and you'll go, अच्छा I'm sorry आपकी शायद नेक्स्ट क्लास स्टार्ट होने वाली होगी, यस, ये यूं जाएगा and the other thing goes that way, okay. So this is the region we want, right? But these critical values are not included, okay, so that's why I'm not making the bold circles, okay. Clear? Shall we stop here, or can I just discuss one more method? Yes.
Sir,
Mm-hmm. Yes, yes.
for the previous one, could you scroll up?
Mm-hmm.
The thing is, for this one, x equals to 1 over 2. When I put it back into this equation, right, I'm getting -9 over 2 is greater than 9 over 2.
1 over 2. Are you getting 1 over 2 or 1 over 4?
9 over 2.
No, like
1 over 4.
1 over 4. So you are getting basically 1 over 4 doesn't satisfy the inequality, but any value smaller than 1 over 4 will satisfy, okay? Right?
Oh, okay. Yeah, yeah.
Okay. So you have to, so 1 over 4 is 0.25, right? So if you consider any value smaller than that, like zero point 0.2 is 1 over 5, right? So if you consider zero point 0.2 and put it back in the inequality, you'll like the inequality satisfies, right? Okay.
Oh, okay then. Yeah, yeah.
Okay. So चल shall we stop here or can we discuss one more thing? Yes, मर्फी आपकी कोई क्लास थी अगर है तो सही है, अगर शुरू हो गई तो हम रोकते हैं.
Yeah, I
ओ,
have another class.
ओ,
शुरू
ओ
हो
इस
गई है.
है बस यही पे रोकते हैं, कल करेंगे. सही, चलो. So okay guys, अभी
Okay.
यहीं तक रुकते हैं. Okay, we'll do one remaining thing tomorrow, and yep, that's it. Okay, take care guys. Allah Hafiz.
Love
I love
it.
this.
Allah Hafiz.